Good morning, students. Warm welcome to chemistry class. I hope all are doing well by the grace of God. Today I am going to teach about in chemistry the first lesson, basic concept of chemistry and chemical calculation. Chemistry, the center of life. What is the importance of studying chemistry in everyday life? Chemistry plays a major role in providing needs of human life in our day-to-day life. Chemistry is everywhere in the world around us. We see chemicals everywhere. We eat chemicals. The food we eat is a chemical only. And the water we drink is a chemical only. Even our body is made up of chemicals. Continuous biochemical reactions occurring in our body are responsible for human activities. Chemistry is widely used in the field of medicine. So, chemistry is everywhere in the world around us. Nowadays, every disease can be cured with the help of medicine. This medicine is nothing but chemicals. Chemicals are widely used in the form of pesticides, fertilizers, insecticides. So, in a different way can be used in agriculture. Chemical industries manufactured useful materials such as polymers, dyes, alloys, drugs, paints, etc. in everyday life. As chemistry plays an important role in our day-to-day life. Classification of matter. What is matter? What do you mean by matter? Look around your house. What do you see? Book, pen, pencil, ball, tumbler, bucket, trees, window, fan, etc. What are these things made of? They are all made of matter. All things that we come across in life are made of matter. All the objects around us are made of some kinds of matter. All kinds of matter possess mass and occupy space. Everything is a matter. All living things, non-living things, everything is a matter. So, matter is defined as anything that has mass and occupies space. All matter is composed of atoms. Then, there are different ways to classify matter. The two most commonly used methods are physical classification and chemical classification. First one is physical classification. Physical classification is mainly based on physical states of matter. As we know already, matter exists as three states, namely solids, liquids and gases. Then chemical classification is further classified into mixtures and pure substances. What do you mean by mixtures? Mixture is nothing but a combination of two or more substances without any chemical interaction. They have been combined in any ratio. There is no fixed ratio. Therefore, mixtures consist of more than one chemical entity present without any chemical interactions. They can be further classified as homogeneous mixture and heterogeneous mixture. Homogeneous means composition is uniform. For example, sugar in water. Sugar particles spread evenly, uniformly throughout the water. In heterogeneous mixtures, the composition is not uniform. For example, sand and water, oil and water. Then what do you mean by pure substances? Pure substances are composed of simple atoms or molecule. We know atom is the smallest particle. All atoms are composed by electron, proton and neutron. Similar atoms combine to form a molecule. Combination of atoms are called molecules. Pure substances are further classified as elements and compounds. What do you mean by element? Scientists have isolated several elements and the list of known elements increased during the days. Currently we have 118 known elements. An element is a pure substance. It consists of only one type of atom. Element can exist as monoatomic or polyatomic units. The polyatomic elements are called molecules. For example for monoatomic unit, gold, copper, silver, platinum. These elements are called monoatomic unit. Gold is made from only one type of atom. Atom is the smallest particle. Is a combination of atoms or molecule. Similar atoms combines to form a molecule. Then example for polyatomic unit, hydrogen, H2, P4, S8. Phosphorus is a molecule. S8 is a molecule. So combination of atoms or molecules. So these are polyatomic unit. Then compound. A compound contains atoms of different elements. Okay, a compound contains atoms of different elements chemically combined together in a fixed ratio. Compounds are made of molecules which contain two or more atoms of different elements. For example, carbon dioxide, CO2, glucose, C6H12O6. Then NaCl, sodium chloride. So compounds are made up of molecules which contain two or more atoms of different elements. Then properties of compounds are different from those of their constituent elements. For example, sodium chloride. Sodium is a shiny metal and chlorine is an irritating gas. But the compound formed from these two elements, sodium chloride, is a crystalline solid. It is used vital role for biological functions. Then the next topic is atomic mass. Atomic mass. What do you mean by atomic mass? That is mass of the atom. Mass of the atom. Children, we know atom is smaller particle. Atoms are too small with diameter of 10 power minus 10 meter and weight approximately 10 power minus 27 kilogram. It is not possible to measure their mass directly. Hence, it is proposed to have relative scale based on a standard atom. The IUPAC Union, which gave an idea. The IUPAC is the International Union of Pure and Applied Chemistry. It is an international scientific organization. The IUPAC, which is decided, considered a carbon-12 atom as a standard one, and its mass is fixed as 12 AMU. AMU means atomic mass unit or 12U. U means unified atomic mass. Therefore, mass of carbon is equal to 12 AMU or 12U. We can say unified atomic mass. The AMU or unified atomic mass is defined as 1/12 of the mass of a carbon-12 atom in its ground state. That is 1 AMU or 1 U is equal to 1.6605 into 10 power minus 27 kilogram. 1 AMU or 1 U is equal to 1.6605 into 10 power minus 27 kilogram. In this scale, the relative atomic mass is defined as the ratio of the average atomic mass factor to the unified atomic mass unit. The formula for relative atomic mass, AR, is equal to average mass of the atom divided by unified atomic mass. For example, calculate the relative atomic mass of hydrogen is equal to The formula of relative atomic mass equal to average mass of hydrogen atom divided by unified atomic mass. Unified atomic mass is 1.6605 into 10 power minus 27 kilogram is equal to the answer is 1.0078 U. U is unified atomic mass. The unit of relative atomic mass is U. So the relative atomic mass of hydrogen is 1.008 U. Since most of the elements consist of isotope. Isotope means what? Elements of the same atomic number but different mass number. For example, hydrogen consists of 3 isotopes: H11, H12, H13. Oxygen consists of 3 isotopes: oxygen O8 16, O8 17, O8 13. Carbon consists of 3 isotopes: carbon 12, carbon 13, carbon 14. Since most of the elements consist of isotopes that differ in mass, we use average atomic mass. Average atomic mass is defined as the average of the atomic masses of all the atoms in their naturally occurring isotopes. Then molecular mass. Molecular mass. What do you mean by molecular mass? Similar to relative atomic mass. Relative molecular mass is defined as the ratio of the mass of a molecule to the unified atomic mass unit. The relative molecular mass of any compound can be calculated by adding the relative atomic masses of its constituent atoms. For example, calculate the relative molecular mass of hydrogen molecule. H2 is a molecule. Atom is H. Single atom is H. In the case of H2, 2H atom combines to give molecules. So, the formula of relative molecular mass equal to number of atoms into atomic mass of hydrogen atom. So, calculate the relative molecular mass of hydrogen means the formula is number of atoms into atomic mass. So, therefore, 2 into relative atomic mass of hydrogen. So, 2 into 1.008. So, equal to 2 into 1.008 U is equal to 2 into 2.0126. But the answer is 2.016. The relative molecular mass of hydrogen is 2.016 U. The relative atomic mass of hydrogen is 1.0078 U. The relative molecular mass of hydrogen is 2.016 U. The second one is calculate the relative molecular mass of glucose C6H12O6. Here carbon, hydrogen, oxygen. The molecular form of glucose is C6H12O6. 3 types of atom. Okay. Then first number of carbon is 6 into the atomic mass of carbon is 12. 6 into 12 plus the number of hydrogen is 12. 12 into the atomic mass of hydrogen is 1.008 plus number of oxygen atom is 6 into the atomic mass is 16. 6 into 16. Therefore, 72 plus 12.096 plus 96. The answer is 180.096 U. This is the relative molecular mass of glucose. Okay, this calculation is very simple. So, you must study the table. Here some relative atomic masses are given in the table. Please study thoroughly. See the table. Hydrogen, the relative atomic mass is 1.008. Carbon 12. Nitrogen 14. Oxygen 16. Sodium 23. Magnesium 24.3. Sulfur 32.07. Chlorine 35.45. Potassium K. K means potassium 39.10. Calcium 40.08. Please Dear students, please study thoroughly. These values are very important. Then only easy to solve the problem. So all do your chemistry notebook. Okay, write the answer in separate chemistry note. Do the given work sincerely. Okay. First one is calculate the molar mass of the following ethanol. But then second one is potassium permanganate. Third one is potassium dichromate. Fourth one is sucrose. First one answer is 46 gram. Second one answer is 158 gram. Third one is 296 gram, I think. Then fourth one is 342 gram. So please write the answer in separate chemistry note. Okay. Then the next topic is mole concept. Mole concept. Before we go to the mole concept, and before we go for knowing what do you mean by mole, let us see some real life examples. Children, often we use special names to express the quantity of individual items for our convenience. So, for example, a dozen of roses, it means for 12 roses. A dozen of bananas, it means for 12 bananas. A dozen of apples, it means for 12 apples. One square paper means for 25 single seeds. Same for chemistry. Large quantity of atoms and molecules are expressed by using the name of mole. Mole is the SI unit to represent a specific amount of a substance. Amount of substances are usually expressed in moles. What is 1 mole? 1 dozen, how can we say? 1 dozen, how can we say? 12 as the number, as well as 1 square means 25. Same for chemical calculation. 1 mole, which represent as 6.022 into 10 power 23 entities. Entities are atoms, ions, or molecule. Now, all of you see the tabular column. Calculation of number of entities in 1 mole of substances. In 1 mole of substance. Here the tabular column is, first one is serial number, then name of substance, then third one is mass of the substance taken, gram, then fourth one is mass of single atom or molecule, gram, then fifth one is number of atoms or molecules is equal to mass of substance divided by mass of single atom or molecule. First one is, the problem is elemental carbon 12. Elemental carbon, that means carbon 12. Find the number of moles of carbon. Calculate the number of atoms present in 12 gram of carbon. We know carbon is an atom. Okay. Then the formula is number of atoms is equal to, number of carbon atoms is equal to mass of the substance divided by mass of single atom. What value is given in the mass of the substance? What value is given in the mass of the substance taken? 12 gram. So, therefore, we substitute the formula. We substitute the value in the formula. Mass of the substance 12 gram divided by 1.9 divided by mass of the single atom. So, 12 gram divided by 1.9926 into 10 power minus 23. The answer is 6.022 into 10 power 23. Okay. So, therefore, 6.022 into 10 power 23 atoms are present in 12 gram of carbon 12. Number of atoms present in 12 gram of carbon, which is equal to 6.022 into 10 power 23 atoms. 12 gram of carbon 12. It means for 1 mole. 1 mole carbon, which contains the number 6.022 into 10 power 23 atoms. The second one is same for glucose. The molecular formula is C6H12O6. Glucose is not an atom. It is a molecule. Therefore, we calculate the number of molecules present in 180 gram of glucose. Actual formula is number of molecule is mass of the substance divided by mass of single molecule. The number actual formula is number of molecules or number of atoms equal to mass of the substance divided by mass of single molecule or mass of single atom. What all is given in the mass of the glucose? 180 gram. So 180 divided by 29.89 into 10 power minus 23. Here we get 6.022 into 10 power 23 molecules. 6.022 into 10 power 23 molecules are present in 180 gram of glucose. The number of molecules present in 180 gram of glucose, which is equal to 6.022 into 10 power 23 molecules. Therefore, 1 mole of glucose, that is equal to 180 gram. Okay, then third one is potassium dichromate, K2Cr2O7. The formula is K2Cr2O7. It is a molecule. So therefore 3 kinds of atom. Okay, then how many molecules are present? How can we find out? First, mass of the substance is taken to 294.8. Mass of the single molecule 48.85 into 10 power minus 23. So apply the formula. Number of moles equal to mass of the substance divided by mass of single molecule is equal to 294.18 divided by 48.851 into 10 power minus 3 is equal to 6.022 into 10 power minus 23. Here the first case, second case and third case, all we get 6.022 into 10 power 23 entities. From the calculation, we come to know that 12 gram of carbon 12 contains 6.022 into 10 power 23 carbon atoms. And the same numbers of molecules are present in 158.03 gram of potassium permanganate and 294.8 gram of potassium dichromate. Similar to the way we use the term dozen to represent 12 entities, we can use the term mole to represent 6.022 into 10 power 23 entities. Here entities means atoms, molecules or ions. Definition of 1 mole. 1 mole is the amount of substance of a system which contains as many elementary particles as there are atoms in 12 gram of carbon 12 isotopes. The elementary particles can be molecules, atoms, ions, electrons or any other specified particles. 1 mole, the defined mole. So please mark this one. 1 mole, defined mole. So the first 3 points. 1 mole is the amount of substance of a system which contains as many elementary particles as there are atoms in 12 gram of carbon 12 isotope. Please note this point. This is a book back question, so please note down. Then the next topic is Avogadro number. Avogadro number. What is Avogadro number? What is Avogadro number? Avogadro number is nothing but 1 mole of anything is Avogadro number. As a scientist named Lorenzo Romano Amedeo Carrillo Avogadro came with this concept. The number 6.022 into 10 power 23 is called as the Avogadro number. The number 6.022 into 10 power 23 is called as the Avogadro number. It is just a number used to represent quantities. Okay, the Avogadro number tells us the number of particles in 1 mole of a substance. These are the particles. Could be electrons or molecules or atoms. The total number of entities present in 1 mole of any substance is equal to 6.022 into 10 power 23. This number is called Avogadro number. Avogadro he proposed theory equal volume of all gases under the same conditions of temperature and pressure. In a chemical reaction, atoms or molecules react in a specific ratio. For example, consider a reaction carbon plus oxygen gives carbon dioxide. The second reaction is CH4 plus 2O2. CH4 is methane plus 2O2 oxygen gives CO2 plus water. In the first reaction, one atom of carbon reacts with one 1 molecule of oxygen to give 1 molecule of carbon dioxide. In the second reaction, 1 molecule of methane reacts with 2 molecules of oxygen to give 1 molecule of carbon dioxide. It is clear that the ratio of reactant is based on the number of molecules. Even though the ratio is based on the number of molecules, it is practically difficult to count the number of molecules. Therefore, using the term mole, we can explain the first reaction as 1 mole of carbon reacts with 1 mole of oxygen to give 1 mole of carbon dioxide, and the second reaction is 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of water. When only atoms are involved, scientists also use the term 1 gram atom instead of 1 mole. Therefore, 1 mole is equal to 6.022 into 10 power 23 molecules. Here the definition of Avocado number is the total number of entities present in 1 mole of any substance is equal to 6.022 into 10 power 23. 1 mole of carbon atom, 1 mole is equal to 6.022 into 10 power 23. Here's some example. 1 mole of carbon atom is equal to 6.022 into 10 power 23 atom. 1 mole of water molecule is equal to 6.022 into 10 power 23 molecules. 1 mole of oxygen gas is equal to 6.022 into 10 power 23 molecules. Then the next topic is molar mass. Molar mass. What is molar mass? 1 mole of any substance is equal to molar mass. 1 mole of any substance is equal to molar mass. Molar mass is defined as the mass of 1 mole of a substance. The molar mass of a compound is equal to the sum of the relative atomic masses of its constituents. The unit of molar mass is expressed in gram mole minus 1. Then calculate the relative atomic mass of one. For example, relative, already you know, relative atomic mass of hydrogen atom is equal to 1.008 U. The unit of relative atomic mass is U, unified atomic mass. Similarly, molar mass of hydrogen atom is 1.008 gram mole minus 1. The unit of molar mass is the unit of molar mass represent as gram mole minus 1. Molar mass is nothing but 1 mole of any substance is equal to molar mass. The relative molecular mass of glucose is 180 U, but in the case of molar mass of glucose is 180 gram mole minus 1. The unit of molar mass is gram mole minus 1. Then already we learned that 1 mole of any substance is equal to molar mass, and it is also equal to Avocado number. 1 mole of any substance, that is 1 mole of carbon atom is equal to 12 gram. That is equal to 6.022 into 10 power 23 mole atom. Then 1 mole of water is equal to 18 gram. That is equal to 6.022 into 10 power 23 molecule. Okay. Then the next one is molar volume. The volume occupied by 1 mole of any substance in the gaseous state at a given temperature and pressure is called molar volume. Here some conditions. Here the table column condition and volume occupied by 1 mole of any gaseous substance. Here first one is 273 Kelvin and 1 bar pressure. Volume occupied by 1 mole of any gaseous substance is 22.71 liters. Then 273 Kelvin and 1 atmosphere pressure, SATP. SATP means standard ambient temperature pressure. The volume occupied by 1 mole of any gaseous substance is 22.4. Then 298 Kelvin and 1 atmosphere pressure is equal to volume occupied by 1 mole of any gaseous substance is 24.5 liters. Then the next topic is important one, gram equivalent concept. Gram equivalent concept, similar to mole concept, gram equivalent concept is also widely used in chemistry. In the previous section, we have understood the mole concept is based on molecular mass. Similarly, gram equivalent concept is based on equivalent mass. Definition of gram equivalent mass. Gram equivalent mass is defined as the mass of an element that combines or displaces 1.008 gram hydrogen and or 8 gram oxygen or 35.5 chlorine. Here the definition of gram equivalent concept is the public question, so please mark this one. The gram equivalent mass is defined as the mass of an element that combines or displaces. The combines or displaces 1.008 gram hydrogen or 8 gram oxygen or 35.5 gram chlorine. For example, consider the following reaction. Zn plus H2SO4 gives ZnSO4 plus hydrogen. Here in this reaction 1 mole of zinc displaces 1 mole of hydrogen molecule. 1 mole of zinc displaces 1 mole of water molecule. That is 1 mole of zinc. Here 1 mole of zinc atom is 65.38 gram of 38 gram. That is 65.38 gram displaces 2.016 gram of hydrogen. Here H2, 2H, so 2 into 1.008. In the definition say, gram equivalent mass is defined as the mass of an element combines or displaces 1.008 gram hydrogen only. Therefore, mass of zinc required to displace 1.008 gram hydrogen is equal to 65.38 divided by 2.016 into 1.008. Here the equivalent mass of zinc is 32.69 gram equivalent minus 1. So, the gram equivalent mass of zinc is equal to, here the answer is 32.69 gram equivalent minus 1. Equivalent mass has no unit, but gram equivalent mass has the unit of gram equivalent minus 1. The second one is, the next one is how to calculate gram equivalent mass. How to calculate, here the next, the page number 9, acids, bases and oxidizing agents. Find out the calculation of equivalent mass of acids, bases, salts, oxidizing agents and reducing agent. Here the formula of gram equivalent mass is equal to molar mass divided by equivalence factor. Molar mass of the substance or gram mole minus 1 divided by equivalence factor equivalent mole minus 1. First, the next one, how to calculate gram equivalent mass. The formula of gram equivalent mass is molar mass divided by equivalence factor. This is the formula to calculate gram equivalent mass. We will see one by one. For the acids, how to calculate. For the bases, how to calculate. Then how to calculate for oxidizing agent or reducing agent, how to calculate, we will see one by one. First one is equivalent mass of acid. Acids, you know, examples of acid: H2SO4, sulfuric acid, HCl, hydrochloric acid, HNO3, nitric acid. These are there are so many acids. Now we see H2SO4, sulfuric acid. It is an acid. In the acids, what are the ions present? H plus, SO4 2 minus. Then HCl, what are the ions present? H plus, Cl minus. HNO3, nitric acid, that is H plus NO3 minus. In all the acids, H plus ion is present. H plus ion is common in all the acids. Now we are going to see equivalent mass of an acid. Equivalent mass equal to molar mass of the acid by basicity of the acid. Acids gives H plus ions. This is called the basicity of the acid. H2SO4 dissociates ionized or split into H plus SO4 2 minus. How many H plus ion in H2SO4? 2 H plus. So the basicity of H2SO4 is 2. Number of H plus ion in sulfuric acid is 2. So the basicity of H2SO4 is 2. So basicity of H2SO4 is 2. அப்போ basicity is number of moles of ionizable H plus ions present in 1 mole of the acid. For example, HCl, H plus Cl minus. Here 1 H plus. So the basicity of HCl is 1. Similarly, HNO3, H plus NO3 minus. Here 1 H plus. So basicity of HNO3 is 1. Now come to the calculation. H2SO4 basicity is 2. 2 equal 2. Now calculate molar mass of H2SO4. We already know molar mass of H2SO4. Molar mass. So molar mass, how to calculate? H2SO4 is equal to number of hydrogen is 2. 2 into H plus 1 into S. Number of oxygen atom is 4. 4 into O. Here 2 into atomic mass of hydrogen is 1. 2 into 1 plus 1 into atomic mass of sulfur is 32 plus 4 into atomic mass of oxygen 16. So the answer is 98 gram. So the molar mass of H2SO4 is 98 gram. Therefore, gram equivalent mass of H2SO4 is equal to molar mass by basicity. Molar mass is 98 divided by basicity 2. Here the answer is 49 gram equivalent minus 1. So the basicity means number of moles of ionizable H plus ions present in 1 mole of the acid. The second one is equivalent mass of bases. What is the formula for gram equivalent mass? Molar mass by equivalence factor. So equivalent mass equal to molar mass of the base divided by acidity of the base. In the previous case for the acids we study molar mass of the acid. Basicity of the acid. Here we study basicity of the acid. Examples of base: potassium hydroxide, calcium hydroxide, etc. Potassium hydroxide dissociates to give K plus OH minus ion. K plus OH minus ions. What are the ions present in KOH, K plus and OH minus ion? In calcium hydroxide, calcium 2 plus plus 2 OH minus ion. In potassium hydroxide, 1 OH minus ion. Calcium hydroxide, 2 OH minus ion. So therefore acidity, that means how many, acidity means that means how many OH minus ions produced in the reaction or in dissociation. Acidity means that means how many OH minus ions produced in the reaction or in the dissociation. Acidity of KOH, 1 OH minus. So the acidity of KOH is 1. Calcium hydroxide, 2 OH minus ion is present. So acidity of calcium hydroxide is 2. Now we are going to calculate equivalent mass of potassium hydroxide. Equivalent mass of potassium hydroxide is equal to molar mass of the base divided by acidity of the base. Here acidity of potassium hydroxide 1. Now molar mass of potassium hydroxide 1 into 1 into K plus 1 into O plus 1 into H. 1 into atomic mass of potassium is 39 plus 1 into atomic mass of oxygen is 16 plus 1 into hydrogen atomic mass is 1. So for the answer is 58 gram mole minus 1. Then last, gram equivalent mass of potassium hydroxide is equal to molar mass by acidity. Molar mass is 56 gram divided by acidity 1. Acidity of potassium hydroxide is 1. So therefore 56 gram equivalent minus 1. Then the acidity definition is number of moles of ionizable OH minus ion present in 1 mole of the base. Next, the last one is how to calculate oxidizing agent or reducing agent. The formula of equivalent mass equal to molar mass of the oxidizing or reducing agent divided by number of moles of electrons gained by 1 mole of the oxidizing or reducing agent. Here oxidation means loss of electron, reduction means gain of electron. Equivalent here equivalent mass of equivalent mass of KMnO4. KMnO4, it is an oxidizing agent. Now calculate the molar mass of KMnO4. Molar mass of KMnO4 is equal to 1 into K plus 1 into Mn plus 4 into oxygen. We know 1 into potassium atomic mass is 39 plus 1 into manganese atomic mass is 55 plus 4 into atomic mass of oxygen 16 is equal to 158 gram mole minus 1. So the answer is 158 gram mole minus 1. So in that acid medium KMnO4, it is an oxidizing agent. So it is reduced during the oxidation. Don't worry about this equation at all. I will explain the next video. MnO4 minus plus 8H plus plus 5 electron minus gives Mn2 plus plus 4H2O. This equation, how many electrons are gained? 5 electrons. There are 5 electrons. So the equivalence factor is 5. Now substitute in the formula. Gram equivalent mass of KMnO4 is equal to 158 divided by 5 is equal to 31.6 gram equivalent minus 1. Here the answer is 31.6 gram equivalent minus 1. Okay. Now today I finished. Next class we will see. Okay. Thank you.